Hi and welcome to Cherry Pie Math. This video is going to introduce how to solve for angles that are missing based off of a diagram with very basic things. We're not doing anything with alternate interior angles if that's something that you're learning right now in class. We're going to focus on basic angle pairs and on triangles. So before we get started, you need to know these four things. You need to know supplementary angles, complementary angles, vertical angles, and adjacent angles, what those are. And you also need to know kind of an idea of their properties, although we are going to go over that better here. So here is a drawing. It's a very simple drawing, something you'll often see when you're introducing especially vertical angles. So remember, vertical angles are angles that are across from each other, that are connected by a point in the middle, I guess. It's when you have two lines that intersect and it's the angles across opposite from each other. So if this one is 40 degrees, this would be its vertical angle. And the cool thing about vertical angles is that they are going to be congruent. And a simple reason for that is we know that a line has 180, oh my goodness, that was a terrible line. We know that a line has 180 degrees, right? We know that this is 40 degrees here, so that means this here is 140 degrees. But that also means that over here, this is a line, and since this is 40, this has to be 140 degrees as well, which leaves that this would also be 40 degrees. So that's a very simple, straightforward proof. Proof is kind of like the mathematical reasoning behind something that you say, but it's why vertical angles are congruent. This would also be 40 degrees. Okay, so some properties of angle pairs that we're going to use is that supplementary adds to 180. Complementary angles add to 90 degrees. Vertical angles are congruent. And adjacent angles are useless. They probably have some kind of a use, but honestly, other than telling me where an angle is, it's not going to do a whole lot. There's no cool properties. I could have any two angles in the world next to each other. They're not going to tell me anything other than they are next to each other. So these are the first three are really what we're going to be using, especially supplementary and vertical. Those are really big. And the other thing we're going to be using often is triangles. So we're going to be practicing with this picture, but before we do that, I'm actually going to go back. What about triangles? In another video, I talked about how no matter what triangle you have, the interior angle sum, that means like this angle plus this angle measure. If you add them all, the interior angle, oh my goodness, interior angle sum is equal to 180 degrees in Euclidean geometry. Any three angles in any triangle in the Euclidean world, which is the world that we live in, is going to equal to 180 degrees. So let's practice with that. So I have here A, B, C, D, and E, and our job is to figure out all of these angles. So let's start with B, I guess. That's as good as any. One thing about vertical angles is you only can use two lines at a time. As you probably noticed, there's a lot going on up here. So one of the tricks with vertical angles is to kind of figure out which two lines that you're working on, and you can bold them or whatever. So I'm going to do this line and I'm going to do this line. And I can see that this angle here is 90. That means that this angle here also has to be 90 degrees. Because I know that vertical angles are congruent. Another one I can do it for is if you see these two here, the ones that make C. These are the two lines that create C, and this is the angle vertical to it. So that means C is equal to 40 degrees. Do you kind of see what I'm doing, where I'm looking at the angle and I'm thinking, okay, which two lines are going to make that angle, and then what would be the corresponding vertical angle for that. So let's do it again. Here's D. These are the two lines that make D. But we actually don't know what A is. So let's try to figure that one out. Okay? We know that this angle here is 90. That means that these two also have to equal 90, right? Because this is a line. We know that this part is 90 degrees, so that means this part has to be 90 degrees. That just follows the logic of 180 degree lines. we already know that C is equal to 40 degrees. That means that D has to equal to 50 degrees, even though it doesn't look like it. And this is why you should never trust a picture, especially in your geometry unit, because half the time, if they're anything like me, they just kind of put random numbers there and hope for the best. That means D has to be equal to 50 degrees in order for that whole thing to be equal to 180 degrees, because 90 plus 50 plus 40 is equal to 180. And like we already saw, A is vertical to D, so that means A is equal to 50 degrees as well. So that solves A through D. Now let's look at E. E is over here by itself. There's nothing around it. It's all by itself. We don't know what it's going to be equal to, but if we know this angle here, we know that that plus E is equal to 180 degrees. We also know that triangles have to be equal to 180 degrees on the inside. So we know that 40, which is this 40 here, plus 35, this one here, plus this missing angle here, we'll just call it question mark for now, is equal to 180 degrees, okay? So if I was to solve it, so then this becomes 75 plus question mark is equal to 180 degrees. And then that means if I subtract 75 from both sides, I should have thought this through better. That means question mark is equal to 105 degrees, right? Yeah, that looks right. Okay, so that means this is equal to 105 degrees. And then if I wanted to find the measure of E, I know that 105 plus E is equal to 180. So that means if I subtract 105 from both sides, that makes E equal to 75 degrees. You might notice that that 75 here is actually equal to whatever 40 plus 35 was, and that totally makes sense because since we know that the triangle is equal to 180 and this is equal to 180, this E would be equal to the same as the other two angles, which is another way you can think about it. I've seen some students do it that way, some students do it the way that we did do it in this video. Honestly, who cares? Just make sure that your logic is following. Make sure that you're not doing just impossible math, that you're not just making up math as you go, but that you're double checking that you have a reason that it equals to 180 or a reason that they're equal to each other. But yeah, that was a quick review, not a review, I guess, but like a quick way of showing how you would use vertical angles to solve for missing angles, how you might use supplementary, how you might use complementary, and how you might use triangles, because the triangles you're going to use quite a bit. So some things to remember is start with one angle and just kind of work your way out. I really like vertical angles. I think they're really easy to find, and I usually try to do as many vertical angles as I can before I move on to anything else because it's just easy for me to find them. But maybe your go-to is supplementary angles. You're a totally different person and you can do it however you feel like as long as you're following those rules. Other angle pairs exist that I didn't show in this video. One really big one starts with alternate interior angles. It's from a theorem about two parallel lines cut by a transversal. It basically says this is equal to that. That's something I'll go over in a later video more in depth, but that's not something I need to do, especially since this video is more geared towards 7th grade math. And those standards focus just on supplementary, complementary, vertical, and adjacent angles. And make sure they add up to 90 or 180 if you're not sure. Don't take anything for granted and make sure they all add up. So double check your math, make sure it adds up to 180 at the end. Okay, I hope that helps and that you're able to solve for some angles.